Hello everyone. So this is the part 2 of the video of how to read datasheet. Okay, so in this video I will give the example of LM75 temperature sensor. So in the previous example I have given the example of BMP280 pressure sensor. So now it will be LM75 temperature sensor. So first we will read the description. So LM75 temperature sensor includes a delta sigma analog to digital converter and a digital over temperature detector. The host can query the LM75 through its I2C interface. So as we can see, it uses I2C interface, and we can give command to the sensor to read the temperature. So its applications are thermal system management, thermal protection. Okay, so wherever like in industries we can use this temperature. And so let's see the interface pin diagram. As you can see, it has 8 pins. First is SDA, second is SCL, third is OS, fourth is ground, fifth is A2, sixth is A1, seventh is 80, eighth is VS. So let's read the description of this pin. So yeah, this is the pin description. So SDA is for like we in I2C we have SDA and SCL. SDA is for serial data input output. SCL is for clock, and OS is over temperature shutdown output. So I think this is when the temperature goes to its above its range, then this pin, from this pin we can sense uh, if its temperature is above its range or not. And GND is ground. A2, A1, A0. Actually these pins are used like in I2C we give the address of the sensor. Okay, so we have to specify which peripheral we are communicating. So these are the addresses: A2, A2, A1, A0. This is the address of the sensor. Suppose if we connect three sensors of this, and we want to communicate to sensor 1, sensor 2, sensor 3, so we can specify from these lines A2, A1, and A0. And eighth is power supply, VS is power supply. So this is a timing diagram of I2C pins, SD and SCL, as you can see. So, and this is a temperature data output format. Like for 0 degree we will have this output. From 0.5 degree Celsius we will have this output, and for plus 125 we will have this output. So as you can see, this range from minus 55 to plus 125. So this is the temperature range of this sensor. And if we talk about its electrical specifications, yeah, this is the electrical specification of the sensor. And we can give a minus 0.3 volt to 6 volt in the power supply. And OS, SD, SCL, these have the range of same minus 0.3 to 6 volt. Input current, it takes of 5 milliampere. So continuous power dissipation at 70 degrees Celsius, it has 362 millivolt. It means when we use the temperature for continuously, so it will consume 362 volt, 362 millivolt at above 70 degrees Celsius. And so this is the this gives the electrical specification in Vs equal to plus 3 volt to plus 5.5 volt temperature specification. This is the actually electrical specification under certain temperature range. Like if we have minus 25 degree to plus 100 degree, minus 55 degree to plus 125 degree. So this is the electrical specification for that range. So if we talk about mean and max, it's minus 2.0 to plus 2.0. they have not mentioned that like this is a voltage or current. Okay, so yeah, this is given here, supply current. Yeah, this is given. If the I2C is inactive, the current it will consume typical 0.25 to maximum 0.5 milliampere. In the shutdown mode, it will consume 4 microampere. So yeah, this is a minus 2.0 plus 2.0. I think this is a temperature range. This is accuracy actually. So when the ambient temperature is minus 25 degree to plus 100 degrees Celsius, the accuracy will be plus minus 2 degrees Celsius. And if the ambient temperature is minus 55 degree to plus 125 degree, so accuracy will be plus minus 3 degrees Celsius. So if we reduce the range of the ambient temperature, its accuracy will increase. Like the lower the value of min and max, the higher its accuracy. Okay. So next, if we talk about, yeah, they have continued from here. They have talked about high and low voltages, high and low current in capacitance. Okay. They have also given graph, like if we vary the temperature, how much supply current it will consume in the shutdown mode, and it also gives accuracy graph. So again, they have provided timing diagram here. This I2C timing diagram. So this is a block diagram of LM75. For most of the cases, we do not need block diagram when we interface to a microcontroller. Sometimes we do need through like how its interfacing is, like how we can access registers. But most of the cases we do not need this. These are the registers, configuration register of the temperature sensor. We can configure using I2C interface. So this is the interfacing. Like for our case, we will see this interface I2C control temperature sensor. We have microcontroller here, and we have provided pull-up registers here to SCL and STA. We do need pull-up register in I2C interfacing. Okay. So yeah, they have also provided OS pin. So that's all about this video. Okay guys, see you soon.